learners.
Good morning, Teacher Jonathan.
Yeah, today I'm very excited to take you through the year KCPE 2014 from number 1. From number
1.
So those who have their boosters, familiar, you get them ready so that we go through the questions that are there. Read number 1.
In a certain country, the population was 38,898,756. What was the population to the nearest 10,000?
Rounded to
The nearest 10,000.
nearest 10,000. So in this question, we are supposed to know place value so that we can be able to round off to the nearest 10,000 first, isn't it?
Yes.
So the examiner here wanted to test two things. One, place value and rounding off. Place value and what?
Rounding off.
So let's go with the place value of these digits. And I write it here. Let's go.
Ones, tens, hundreds, thousands, tens of thousands.
So we have gone up to tens of
Thousands.
We have gone up to tens of what?
Thousands.
This is the one we want to round it off, right?
Yes.
So we'll underline the digits before the 10,000. Can you read the digits before the 10,000?
8,756.
8,756. Then 10,000. What is the half of 10,000?
Half of 10,000.
Half of 10,000 is supposed to be what?
5,000.
So if this digit has reached 5,000 or is more than 5,000, what have I said? If these digits have reached what?
5,000.
Or is what?
More than 5,000.
Then we shall promote this 10,000 to the next 10,000. To the next what?
10,000.
But if these digits we have underlined have not reached 5,000, are below half of 10,000, these 9,000, these tens of thousands will remain the same. Will remain what?
The same.
So, what can you say about 8,756?
It is more than 5,000.
It has reached its more than, isn't it?
Yes.
So it is closer to a 10,000. It's closer to a what?
10,000.
So we promote this 10,000 to the next 10,000. We promote it to the next what?
10,000.
So this changes them to be 0, 0, right? Then we add 1 to 9, we get what? 10. We write 0 at 1. We add the 1 there, it becomes what?
9.
Then this is 8, 9. So the answer becomes what? 38,900,000. 900 what? A quicker way to do this. A quicker way to do?
That.
So we have all the digits we use in mathematics range from 0 to
9.
And then from them we get what? We divide them into 2, isn't it?
Yes.
How many digits are this?
5.
There are 5, there are 9,
10.
there are 10,
10.
there are 9, there are... How many digits are this?
10.
Let's count them. Let's just count them.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
They are 10 because, okay, some of you looked because it's going up to 9. That's why some of you are saying 9. But remember, I've started with what?
0.
So the total digits here are 10. So what is a half of 10?
5.
5. So the first 5 I put them together. 1, 2, 3, 4, 5. Those ones I put them together.
Together.
Then I write same. I write what?
Same.
And then the other digits I put them together and I write what?
Next.
Are we together?
Yes.
So now this time we are only going to look at the digits which is after, before the 10,000. The 10,000 is here, right?
Yes.
And we just look at the digits just before the 10,000. We look at the digit before the 10,000. And which is that digit before the 10,000? 8. We look at this, what we have formed here. Does 8 belong to same or next?
Next.
It belongs to next, isn't it?
Yes.
Because these digits are the ones which are more from half and more, isn't it? So that means that we are going to promote this 10,000 to the next 10,000. We are going to promote it to the next
10,000.
So we add 1 to this 10,000. We add 1 to that 10,000. Remember these ones, we convert them to zeros. All of them including this. Then because 8 belongs to the next, we add 0 there. We say 1 plus 9 is 10. And we carry 1. We get what? 9, then 8, then 3. We get 38,900,000. These days we don't put commas, we space. We do what?
Space.
After 3 digits, you put a space. 1, 2, 3, space. 1, 2, 8, space. 1, 2. These ones have not reached 100 million. So are you together? So number what? Number 3, yeah? Number 3.
Number 2.
Number 2, yes. Can you read number 2?
What is the largest 6-digit number written in words that can be formed using the symbols?
The largest 6-digit number. The largest 6-digit what?
Number.
That can be formed from 4, 2, 0, 8, 3, 6. These are digits. This is not a number. These are what?
Digits.
We want to make a number from these digits, right?
Yes.
So Esther, how do we form the largest 6-digit number? We start with the largest digit, which is 8, followed by
6.
the second largest. Say that.
The second largest.
Which is
6.
the third largest is
4.
4,
3.
2,
2.
then 0. Are we together?
Yeah.
So the number becomes what?
864,320.
I pose another question from here. The smallest 6-digit number. The smallest 6-digit number. Eddie, what do we do to get the smallest 6-digit number from this?
We begin with the smallest digit.
We begin with the smallest digit. Class, is that right?
No,
Okay, correct him.
you begin with the second smallest digit.
Can you clap for her? A clap. Why are we saying it's right and it's wrong? She's right and he's wrong. Who can tell me? Why don't we begin with the smallest digit number? Yes, correct yourself. Thank you.
I'm correct.
Yes.
Because not all digits have 0. Not all of them.
Oh, very good. But for this particular one, there's a 0, isn't it?
Yes.
So, very good. Clap for him. He has corrected himself. So, this one has a 0 now. So, what do we start with?
We start with the second smallest.
We start with the second smallest digit, which is what? 2, followed by now the 0. The smallest is 0. Then we have what? 3, 4, then 6, and 8. Why didn't we begin with 0? Mashi? Yeah, if you start a number with 0, it will have no value. It will have no what?
Value.
So what will be the value of this number? It's like this number has just gone up to tens of thousands, isn't it?
Yes.
Because in the hundreds of thousands, there is no digits. This digit here has no value. Are we together?
Yes.
So when you start a number with 0, the 0 will have no value. It will have no what?
Value.
It will have no value. Are we together?
Yes.
So if the number has a 0 at the end, then those digits that are 0, don't start with a 0. Start with the second smallest. Start with the second what?
Smallest.
But if I give you numbers like 1, 4, 2, 6, and then 8, and I told you to form the smallest, what will you start with? As Eddie was telling us, now you start with the what? The smallest digit, the second smallest, the third smallest, the fourth, and the fifth. You get 12,468. Are we together?
Yeah.
Yes. Number 3. Number 3.
What is the value of?
Yeah, value of that. So in your boosters, correct, they have not written squared. The original paper is supposed to have squared. Can you see they have not squared 6?
Yes.
Correct that. 7 times 2 all over. So what are we supposed to do in such a question, Mikali?
Use board mass.
Use board mass. Yeah, a clap for her. We use what?
Board mass.
So in board mass, this means what?
Square.
We work out squares first. Brackets.
Of. Division. Multiplication. Addition.
And subtraction. A caution. Don't try to divide 3 with the end of the digits up here. Don't try to divide 2 with end of the digits up where? Here. Work out everything in the numerator until you get one answer. Until you get what?
One answer.
Then you work out the denominator until you get one answer. The answer you get here, divide with the answer you get what? There. Are we together? So don't try to divide anything from the numerator and denominator, right? So we start with the numerator, is the one which has a lot of bonds, isn't it?
Yes.
We start with the what? And if you look at the bracket on the numerator, which side should start here? Which side should start?
Square.
We square, isn't it?
Yes.
We square 8 squared, which becomes 64, and 6 squared becomes 36. So we have 26 plus 64 plus 36 minus 56 divided by 7 times 2. Who can tell me the next operation? We first work out with the numerator alone. We have worked square, there is no bracket, there is no off, we go to division. We divide. We do what?
Divide.
So what is 56 divided by 7? How many times does 7 go into 56?
8.
Take care. In some of the exams you can be given 7 divided by 56. What is 7 divided by 56? Just a quick one. It's an 8 because this will be 7 over 56, which is the same as what?
An 8.
But this is 56 divided by 7, which is 8. Take care of that, right? Yeah. So we now rewrite the question without division. 26 plus 64 plus 36 minus 8 times 2. Clap for yourselves because you are doing a good job. After division, we go to what?
Multiplication.
Pick multiplication. What do we multiply?
8
times 2. So we have 26 plus 64 plus 36 minus 16. We go to what?
Addition.
We go to what?
Addition.
What do we add?
26, 64, 36.
Why don't you do that within a second? 26 add 64 add 36. And I will give you a banana if you get it. The first one.
126.
Good, I will give you a banana to charge your phone. So, and you told us a banana can charge your phone, isn't it?
Yes.
I will give you a banana to charge it. So we get 100 and what?
26.
126 minus 16. 126 minus what?
16.
Then what is 126 minus 16?
106.
106. This is what you have got from the numerator, right?
Yes.
So we say now 106 is our answer from the numerator, isn't it?
Yes.
What's our answer from the denominator?
Teacher, it is
Teacher,
not 110.
10. Here, oh yeah, 110. So Eddie, you are wrong, isn't it?
Yes. Teacher, take back your banana.
Of course, it goes back to somebody else. So 110, right? You must be very accurate, right? Yeah, 126 minus 16 is 110. So we get 110. We divide by 3 plus 2 is what?
5.
5, right?
Yes.
110 by 5. Jump. 2. Here we get what? 2. We get what? 22 is the answer. 22 is the what?
Yes.
I just want to give you a small question on addition and subtraction. On what?
Addition.
Remember, division, we are just picking where it is. Just picking, isn't it?
Yeah.
But when it comes to addition and subtraction, there's a question you need to take care of, right?
Yeah.
Like I give you 9 minus 6 plus 1. Right?
Yeah.
Somebody can just come the way we are picking and just pick addition, and then you say you tell us 9 minus 7, and you tell us the answer is 3. This, 9 minus 7 is what? 2. This is wrong. This is what?
Wrong.
Why is it wrong?
Because you are
In addition and subtraction, this is what this means. Let's go. 9, take away 6, add 1. Let's go.
9, take away 6.
Add 1. So the number to be subtracted is that, right? So we get 9, we add 1 first, which gives us what?
10.
Then we take away 6, which becomes what? 4. Which becomes what?
4.
So take care of addition and subtraction. But multiplication, division, you just pick them where they are, right? So take care of this. I will give you a question to later to see whether you have understood that, right? And I will give you a what?
A banana.
Banana to charge your what?
4.
Alright, let's go to number.
Another words, teacher.
Yes, please.
What we mean there when we are talking about addition and subtraction,
Yes, please.
it is very simple, okay? Just look at the sign before the number. sign
before the number.
before
The number.
the number. Okay?
Yes.
Tells you whether that number has a positive or a negative.
A negative.
So when you look at the equation that teacher wrote, 9
plus
minus 6
plus 1.
plus 1. Okay?
Yes.
So look at, and when a positive number begins, we don't indicate. Okay?
Yes.
So if I write 9, this means a positive 9. When it's a negative, always it must be indicated as to be negative 9. Right? So for these numbers, check 9. No sign before it. It means a negative. I mean a positive.
A positive.
Look at 6. The sign before 6 is what?
Negative.
Meaning this is negative what?
6.
6. Let us look at 1. The sign before it?
Positive.
Positive. Meaning this is a positive 1. So tunaanza na positives. We pick the positives. Ambayo itakuwa ni 9. Another positive plus 1 minus 6. Okay? Then we rearrange them. Okay?
Yeah.
So 9 plus 1 gives what?
10.
Minus 6. 10 minus 6 gives you what?
4.
Right?
Yes.
Beautiful clap for the teacher. Good. And we are coming back with this, right?
Yes.
Because in algebra, this is what gives children a problem, right? We shall come with questions like 9 minus 6 minus 1. I know when you get to such things, you start getting confused, isn't it?
Yes.
So we are going to get back to this soon when you are doing algebra so that you can know how to do that, right?
Yes.
So number 4. Number 4, can we read number 4?
In the number, 30,700, 3,000. In the number, 3,078,642.
For you to read this number without confusion, you start from this digits, you count 1, 2, 3, group those together, right?
Yes.
1, 2, 3, group those together. Then this one is alone. These are hundreds, tens, and ones. These are thousands, right?
Yes.
Thousands, tens of thousands, hundreds of thousands. These are all thousands put together, right? Then this on this side, the other comma here, these are what? Millions. These are what?
Millions.
So we start with the millions. Read.
3,078,642.
Beautiful. So we are told in the number 3,078,642, the total value of digit 7 is added to the total value of digit 4. Which of the following is the correct answer? Is the correct what?
Answer.
So I want you to watch what I'm going to do as I write the total value of these digits, right?
Yes.
So I'll just come below the 3 here. I write another 3 there. I write another what?
3 there.
Then everything else here I write 0. Matching properly. Matching
Properly.
and that tells me the total value of this is what? 3 million. It's 3 what?
Million.
Where there is 0, I just write 0 there, and then I put what? Zeros like that. So the total value of this one is what? 0. I come to 7, just below the 7. I write 7, the rest I convert them to zeros. This tells me the total value of 7 is what?
70,000.
Just below the 8,000, I write 8, the rest I convert them to zeros. This tells me this is what?
8,000.
Just below the 6, I write what?
0.
This tells me this is what?
600.
Just below the 4, this becomes what? 40. Just below the 2, I get what? 2. So this is the, why are you not clapping for me? This is beautiful. So this is how we write total value. This is how we write what?
Total value.
Or value. If you are just told to find the value and they have not said place, it is total value. It is total what?
Value.
So from here we are now easy to get the answer. The total value of digit 7, we just pick where it is. It is 70,000. It is what?
70,000.
And we are doing what? We are adding the total value of digit what?
4.
Which is what? 40. It gives us what? It gives us what? 70,040. It gives us 7,000 and what?
40.
This question can be reframed and asked. By how much? Can you repeat my statement?
By how much?
Is the total value of digit 7 greater than that of 4? Repeat.
By how much is the total value of digit 7 is greater than digit 24.
Yes, by how much is it greater? What will I do? You subtract the total value of digit 7 minus the total value of digit 4. You get 69, it's greater by 69,906, right? I reframe the question and ask, by how many times, repeat that,
By how many times
is the total value of digit 7 greater than that of digit 4? Can you repeat that? By how many times?
By how many times is the total value of
In such a case, Mesh, what we do? Divide. Because the opposite of times is what? Division. Is what? Division. So we get 70,000. We divide by 40. Divide by what?
40.
We get by 2, 2, by 2, 35, 0, by 2, 1, by 2, 1, 7, 2, 0. So it is 1,720 times greater. It is 1,720 times greater. Meaning, if I get 1,720, I do what?
Times
40. I will get the number 70,000. Have I gone wrong in the division?
It's supposed to be 5.
Yes.
Where is the division? Where?
There.
1750.
17 what? Yeah. A banana for the teacher.
No, for the teacher.
Yes, not for any. So it is 1,750. Yeah, Nelly is the one who told us 2 there. So if now if I have to see what I'm saying, 40 is 1,750 times greater than 70,000, right? Because when I get 1,750 times 40, that's when I get 7,000, right? Some candidates, when they are told by how many times is it greater, they subtract. That's wrong. That's what? Wrong. You're supposed to divide. You're supposed to do what?
Divide.
If you ask by how much, that is the time we are supposed to subtract. So when you're writing total value, remember to do that, right? Let me just see whether we are understanding. Esther, write the total value of every digit here. Come here. 6, 9, 2, 1, 5. Write the total value of each digit. Of each digit. Yeah, just continue. So the first digit is 60,000. The other digit is what? 9,000. The other digit is what?
200.
The other digit is what?
10.
The other digit is what?
5.
Those are the total value of clap for her. Good, we got to number 5. I hope it's not yet 10.
Me too.
Is it 10?
3 minutes.
We are going to do number 5, isn't it?
5 and 6, yes.
Yeah.
What is the
Yes?
What is the value of 3/5 plus a quarter into brackets a half minus a fifth of 2/3 divided by a third?
Yeah, here we have to apply what?
Bonus.
Bonus. We have to apply what?
Bonus.
And I want you to watch what I will do in this question keen, yeah?
Yes.
Yeah, so what am I supposed to do? I'm not supposed to work out using bonus, right?
Yes.
So what is the first sign here? Do we have squares?
No.
Do we have brackets?
Yes.
We are supposed to start with what?
Brackets.
Brackets. So I start with bracket here. Now take care. Take what?
K.
I will include the quarter. Yes. Why?
Because that is
It is part of the bracket.
Bracket.
If it was 3/5 plus a quarter minus or plus into bracket something like this, the bracket would be gone up to here, right?
Yes.
But if there is no sign here, it means whatever is in the bracket, repeat,
Whatever is in the
has
bracket
to be multiplied by a quarter.
has to be multiplied by a quarter.
When we are removing what? Brackets. Are we together?
Yes. Yes.
So now, when we are removing brackets, we have to include their quarter. We have to include the what?
A quarter.
So you just come somewhere here, side where you're doing your rough work, right?
Yeah.
You work out that. You work out what?
That.
Right? So a half minus a fifth, we get a half minus a fifth. LCM is 10. 10 by 2, 5, 5 times 1, 5, 5, 10 by 5, 2, 2 times 1, 2. We get what? 3, 10 times a quarter. We get what? 3 over 40. Just watch what I'm going to do. Now I rewrite the question without brackets. Without what?
Brackets.
3/5 plus 3 over 40 of 2/3 divided by a third. I've worked brackets, right? Now I work out of. What do I work out? Of. So I underline of and I come here to the side. 3 for 40. Of is like multiplying, isn't it?
Yes.
Only that it comes before multiplication. That one gets 20. 3, 1, 3, 1. We get what? 20. So we get 3/5 plus 1 over 20 divided by a third. Divided by what? Right? What comes after this? Division. We divide. Remember, Eddie, when we are dividing, we are supposed to change this into multiplication, and the second fraction we do what? Reciprocate. If it was a 3, it becomes 1 over 3. If it was a third, it becomes 3 over 1. So times 3 over 1. Times 3 over 1. It becomes 3 over 20. So we have 3/5 plus 3 over 20. There are 2 ways now to add this. There's no multiplication. So there are 2 ways to add this, isn't it? One is finding LCM, the other one is renaming. Which of the two do you know? LCM, isn't it? Okay, good. But I will still show you renaming. I will still show you what?
Renaming.
Let's go for LCM. LCM of 5 and 20 is what? 20. 20 by 5? 4 by 3?
12.
20 by 20? 1 by 3? You get what?
15 over 20.
Never leave a fraction without simplifying. By 5? 3. By 5? 4. We get 3/4. We get what? 3/4. How would I have added this by renaming? Sabah? Yes?
That 3 over 5
Yes.
is multiplied by 4.
Yes.
Both the numerator.
We look at these two denominators. We look at the larger one is 20, isn't it? I ask myself, how do I make 5 to be like this denominator? Right? I have to multiply 5 by 4. So I multiplied 5 by 4 to become 20, isn't it?
Yeah.
And what I've done to the denominator must be done to the numerator. So this becomes what? 12 over 20, right? So we have 12 over 20 added to 3 over 20. And we know when the denominators are the same, we don't find LCM, isn't it?
Yes.
We just add them to get 15 over 20. So that's what we call renaming. That's what we call what?
Renaming.
We get 3/4. Right?
Yes.
Thank you for watching my YouTube channel, and we shall continue the next lesson. Bye.
And he was